Good morning, students. In the last class, we had discussed about characteristics of chemical reaction and chemical equation. Today, we are going to start with the topic balancing of chemical reactions. Students, this is a very important topic as per your board examination. So let's start it. Every reaction should be balanced to satisfy law of conservation of mass. According to this law, masses should be conserved, that is, number of atoms of each elements of reactants should always be equal to products. In other words, we can say that number of atoms of each element remains same before and after a chemical reaction. Hence, we need to balance a chemical reaction. Here is pictorial representation of unbalanced and balanced reaction. You can see in the picture, unbalanced means the left hand side or one side we can say is not equal to the other side, and balanced means both the sides are equal. For better understanding, here I have taken an example of hydrolysis of iron. The equation is Fe plus H2O, that is water, gives Fe3O4 plus H2. So let's start to balance the given reaction. First step to balance a reaction is draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. You can see it in the slide also. After the first step, the second step is list the number of atoms of different elements present in the unbalanced equation. As you can see it on your screen, the number of iron is 1 on left hand side and 3 on right hand side. Number of hydrogen is 2 on left hand side and 2 on right hand side. And oxygen is 1 on left hand side and 4 on right hand side. So we need to balance this equation. Step 3 is to balance the compound which contains maximum number of atoms. It is often convenient to start balancing with the compound that contains the maximum number of atoms. Using this criteria, here we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the right hand side and only 1 on left hand side. For balancing, we can multiply water with 4 in reactant side. Now, the partly balanced equation is Fe plus 4H2O gives Fe3O4 plus H2. Now, moving towards the next step, that is step 4, is check the other elements whether they are balanced or not. Here, iron and hydrogen atoms are still not balanced. To balance hydrogen, multiply H2 with 2 in product side. Now the equation becomes Fe plus 4H2O gives Fe3O4 plus 4H2. Now we can see that only one element is unbalanced, that is iron. So for that we multiply iron with 3 in reactant side and the equation becomes 3Fe plus 4H2O gives Fe3O4 plus 4H2. Now this equation is balanced because the number of atoms of elements on both sides are equal. Now I have given you various worksheets regarding the balancing of equation. So try to solve all those worksheets. Now, after balancing, the next thing which came in our mind is whether the balanced chemical equation gives us all information about the chemical reaction or not. So let's discuss that how we can make the equation more informative. So following are the ways to make it more informative. Very first is by stating the physical state in symbolic form for reactants and products participating in reaction. For example, small s for solid, L for liquid, G for gas, etc. Second is indicating the gas evolved during the reaction by upward arrow. You can see it in diagram how you can show the upward arrow. Third is indicating precipitate in the reaction by downward arrow. Now the precipitate term is I think new for you. The precipitate means the insoluble solid formed during a reaction. Okay, it has curdy appearance, white cloudy like appearance. So if there is formation of any precipitate in the reaction, you can show it by the downward arrow. Next is indicating the reaction conditions like temperature, pressure, catalyst if used above or below the arrow. So if any specific criteria is used for a reaction, you have to show that above or below the arrow. So by these 4 points, we can make the balanced chemical equation more informative. Now, moving towards the next topic. The next topic is types of chemical reaction. So, during a chemical reaction, atoms of one element do not change into those of another element. Actually, chemical reaction involve the breaking and making of bonds between atoms to produce new substances. The very first type of chemical reaction is combination reaction. Now, combination reaction is that reaction in which two or more than two reactants combine together to form a single product. As for example, calcium oxide, that is CaO, reacts with water to give CaOH whole twice, that is calcium hydroxide. Here, in this example, you can see that combination reaction is a synthesis reaction. If you combine sodium and chlorine, you get sodium chloride. So Na plus Cl2 gives NaCl. This is also one of the example of combination reaction. The general form of combination reaction is A plus B gives AB, where A and B are reactants which gives the product AB. Here are some more examples of combination reactions like carbon plus oxygen gives CO2, hydrogen plus oxygen gives water. After the combination reaction, second type of reaction is decomposition reaction. This reaction is just opposite of the combination reaction. It is that reaction in which single reactant breaks down to give simpler products. For example, ferrous sulfate crystal lose water when heated and the color of crystals changes. It then decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. So the reaction is 2FeSO4 on heating gives Fe2O3 plus SO2 plus SO3. Here are some more examples of decomposition reactions. Like hydrogen peroxide decomposes into water plus oxygen. Then water on electrolysis decomposes into hydrogen and oxygen. Nitrogen triiodide decomposes into nitrogen and iodine. Its general form is AB gives A plus B, where AB is reactant and A and B are the products. Now there are several types of decomposition reactions which are based on sources by which reactants are decomposed. So moving towards the first type of decomposition reaction, it is thermal decomposition. When a single substance breaks into two or more simple substances on heating, then it is called as thermal decomposition reaction. The meaning of the term thermal is heat. So if the decomposition is due to heat, it is thermal decomposition. The example you can see here, CaCO3, that is limestone, on heating decomposes into CaO and CO2. Another example of thermal decomposition is lead nitrate decomposes into lead oxide plus nitrogen dioxide and oxygen. That is PbNO3 whole twice gives PbO plus 4NO2 plus O2. Here you can see the next two types of decomposition reaction. First diagram shows electrolytic decomposition reaction in which decomposition takes place due to electricity. The example is electrolysis of water. Second diagram shows the next type of decomposition reaction, that is photodecomposition reaction. Means the decomposition due to sunlight, or we can say light. The meaning of the term photo means light. So if the decomposition takes place due to light, then it is called as photodecomposition reaction. Some examples of photodecompositions are silver chloride decomposes to give silver plus chlorine. You'll see that white silver chloride turns grey in sunlight. This is due to photodecomposition of silver chloride. In the same way, silver bromide in the presence of sunlight decomposes into silver and bromine. These reactions are used in black and white photography. Students, it is a very important question that why silver chloride and silver bromide decomposes in sunlight. Now let's summarize. Today we read balancing of equation, how you can make reactions more informative, then combination reaction and decomposition reaction. So in the next class we'll continue with the other types of reaction. That's all for today.